evening, parents and students. Hope you're doing well. This is a note video, so you're going to need a piece of paper and a pencil. And we've looked at multiplication comparisons for short math statements. Now we're going to include a model called a ribbon or tape model to go along with our multiplication comparisons. This is notes, so you're just going to follow along. There's nothing for you to do except watch the video and take the notes and build an understanding of how this model kind of resembles some of the other models we've seen, like arrays. So the statement and the equation and the model still all have to agree, and this is an exercise in looking at that. I'm kind of excited because we're in week 20. So that means that we're almost through half of the school year. It's been a very strange school year, to say the least. And for the first 20 weeks, you have learned basically everything you need for fourth grade, and now we're going to start applying it. We're going to look closer at not just reading as itself, but just looking at reading and how things are arranged in reading. We're looking at how to apply that to writing, which is something new for the next 20 weeks. And we're starting to take a lot more notes. So get a spiral notebook. This is going to be some more notes on Mr. Buddinger's three-number principle. I'll put that in kind of in the center of the paper. Principle. Three-number principle. Now we looked how we can use multiplication using three numbers. We could start with a number with the product 24, and we know we have to come up with a minimum of two more numbers. So this is 24 and two more numbers. So this is three numbers here. This is that three that we're talking about here. So there could be a variety of different answers here, but the product has to be 24. So it could be, one of my favorites is 4 and 6 would make this statement true. Okay. Then we looked into writing statements about this in math nomenclature, which are short math statements that give meaning to how we would describe this equation. And we said that 24 is, okay, 4 times, okay, so 24 is 4 times, and this was the harder part, as many as 6. So this is a short math statement. We call that nomenclature. And it describes these two. And these two we said are equivalent, which is this symbol here. They aren't exactly the same because this is just numbers with symbols and this is words with numbers, but they mean the same thing. So that's what equivalency means, is they mean the same thing. They may be two different kinds of things, but they're equivalent in their meaning. And then we said, okay, so how would we describe this in a model? And we said, okay, 4 times as many as 6. So this is telling me how to arrange my model. I'm going to have 6. Well, first I'm going to make, things that are 24, so we're going to use our dots. We don't necessarily have to put them in an array, but we could. Let's put this in an array this time. And it's going to be 24 of something 4 times as many as 6. So let's put 1, 2, 3, 4, 5, 6. Let's put 6 columns here, or 6 in each column 4 times. I like to use the number 24 because you can do so much with the number 24. It has so many different answers that we do here. And we just choose 4 and 6 for this particular example. Now we have to arrange these to agree with our equation and now our short math statement here. So I'm multiplying 6 4 times. Sometimes we kind of reverse that a little bit. So it's going to be groups of 4 or groups of 6 4 times. You notice how I kind of go backwards between these two. That's a little confusing, I understand. Math can do that sometimes. Sometimes the nomenclature of math is the hardest thing to get an idea about. So remember, we put our 4 down here. This is how many columns we have. Or I could put my 4 up there. That's how many times we're multiplying 6 in each row here. And that equals 24. So here's an equation, here's a statement, and here's a model. The statement is something new, so you're going to see that in your packet as well. I'm going to introduce a new model for what we call this is multiplication comparisons. I'm going to introduce a new model. It looks just like this. It looks like a very long rectangle. Now, we're going to keep with our Mr. Buddinger's 3-number principle. So this model has 3 numbers, 6, 4, and a 24. This model is going to have the same thing. It's going to have a 6, 4 times the 6, and 24 altogether. This is called there's several names for this. You're going to see this on your test at the end of the year. It is called either a ribbon, because it kind of looks like a length of ribbon. I've heard it called a tape model. Looks like, looks like a piece of tape, right? Like that. Also, it looks like a bar. Like if this was a bar of steel, it could look like that also. Model. So we're going to call it a tape model for now, just because I'm more familiar with that. But again, it could be any one of these 3, but I'm going to call it tape because we use a lot of tape. And we could actually take a piece of tape and do that. I don't have much ribbon around, and I don't certainly have a bar of steel around, so we're going to call this a piece of tape, or a tape model. Now, how could I make an equivalent tape model to my dot array, my statement, and my equation? How could I do that? I'm going to show you. It's rather quite simple, but again, it has to agree with everything that's here. So I know that my total, my product here is 24. So this whole thing is going to represent the total amount of 24. So now we're getting into something so more abstract. So this is kind of a more abstract model. You can use it to solve a lot of different word problems, especially word problems having to do with multiplication comparisons. But it still has to agree with everything that's here. So if this is the whole amount of 24, whatever it happens to be, we're going to indicate that as a length. Now it doesn't necessarily have to be a length, and I'm going to show you why. But we're going to say from this end all the way to this end is the total product of whatever we put in here. Now, we have 4 times 6. So we're going to take this bar, this tape, this ribbon, and we're going to divide it into 4 equal parts. The easiest way to do that is put a line down the middle and then divide what's left in half. And that gives us 4 boxes. And in each box, just like we had here for our circles, we aren't going to use like dots, okay? And these dots, again, can be examples or units of gumballs, M&Ms, erasers, whatever it is. We're going to not kind of look at that just yet. But we're just going to use these symbols. We're looking at Mr. Buddinger's 3-number principle. I'm going to, now so I look this up here, I'm going to make this a capital 2, like a title. Okay? So we're just going to use this number 6, and we're going to put the 6 in here in these boxes. So if these dots here represent, let's say, M&Ms, okay, that's our units, is M&Ms. I could say there's 6 M&Ms in this compartment. So let's say this is a long connection of boxes. Because remember, each time we do connect something like this, we're adding it together. So we're adding this box to that box to this box to that box. And whenever we take the same number and add it multiple times, that is what multiplication is. So we're going to take, so we've got our 24 here. We've got our 6. Now we have this last number here with the multiplication symbol. We're going to say 4 times on the top. So this is a completed ribbon model. Now, even though I have 6 4 times here, it's the same number. So we aren't going to include the amount of numbers. We're going to say this is still 3 numbers, because even though I repeated 6, it's still just one number. I didn't repeat the 4, I didn't repeat the 24, so we're okay there. So this is 1 number, 2 numbers, 3 numbers. Even though the 6 is a number of different times, it's still the same number. We only have 3 numbers here still. So I'm going to introduce this in this week's math of the ribbon model and the short math statement and the equation. We're going to have all 3 of these agree in your packet for week 20. And down here, we can draw a line down here. Let's just draw a line down here. I'm going to give you 2 equations up here, and I want you to come up with the models down here. So let's use the equation 5 times 8 equals, and you come up with the product. So there's one example. We'll call this example A. And for example B over here, come up with 4 times 10. Let's pick another number like that. And that's kind of an easy number to do as far as the equation is concerned. But what would your, make a ribbon model down here. Make a ribbon model. So I'll get you started. So we don't have to make them different sizes because, again, this is abstract. These are not going to represent any type of particular size. They can all look the same size. How would you indicate these equations using a ribbon model? And then there's some examples in your homework, both using the short math statements, the ribbon model, and the equation. This might be a little bit difficult to wrap your head around, but go ahead and make 2 of your own, and we'll practice that this week.